All right, so on this one, we had multiple graphs. This is just the solution, but I want to show you how you can think about finding the right answer. So first thing you'd want to do is look at your polynomial and find that number on the end. That's going to be your y-intercept. So this one clearly has a y-intercept at -3, so that would be a possible answer to your problem. Now, I'm assuming there's other graphs like this that have the same intercept, so you can't just use the intercept. But there's a bunch of these x-intercepts, so how can we find all those and then match it with the correct graph? Well, to find the x-intercepts, you let the function equal 0 and solve for x. Now, when you have x squared, you can use quadratic formula or factoring. When it's x cubed, it's a little trickier. What we notice is that these both have, this is like 1x cubed, 1x, 3, and 3, so we can factor by grouping here. Let's take the x cubed and put it with the negative x plus 3x squared minus 3. And what we're allowed to do then is we can kind of look at it as two separate pieces. On the left here, we have x times x squared minus 1 plus, and on the right, I can factor out of 3 and get x squared minus 1. When you factor each of these separately, you notice they have a common factor. So you can factor this out of that, and you end up with x plus 3 times x squared minus 1. So because this term had an x squared minus 1 and this had an x squared minus 1, you basically factor those out and you're left with x plus 3. Now we have two things times each other. We can use my zero product property. X plus 3 equals 0 and x squared minus 1 equals 0. Well, this one is just x equals -3. This is x squared equals 1. X is equal to plus or minus the square root of 1. So x would equal -1 and +1. Now we would go back to our graphs and say, okay, which graphs have an intercept of -1, +1, and -3? Well, here it's -3, there's -1, there's +1. So this particular graph had all three x-intercepts and the correct y-intercept. And then you would just compare it with the other 3 or 4 graphs and basically eliminate the ones that don't have the correct intercepts, and you'd be left with this one.